Today we're going to be talking about parametric equations. And parametric equations are equations that have an ordered pair, x and y, but where the function for x and the function for y are different and not related to each other. In comparison, we also have the rectangular form of an equation, which is sort of what we're used to, where y is a function of x. If you notice here, when we're graphing parametric equations, we're going to get an ordered pair, x and y. But x is a function of another variable, t, and y is a function of another of that same variable, t. Now, t is going to be what we're going to know as the parameter. So that third variable, t, is going to allow us to separate my x and my y into two different equations, and it's going to allow us to do a couple of things that we can't do with the rectangular form of an equation. For example, one of the reasons that we're going to want to use parametric equations instead of its rectangular form is to bypass the vertical line test. And I'm going to show you guys exactly how we do that a little bit later. But for now, what's important is that you know that in a parametric equation, x and y both have different functions, and that differs from rectangular form in which x and y are functions of each other. The graph of a parametric equation is going to be known as a parametric curve, and a parameter interval is going to be this right here. So we're about to get into that right now. Let's go through a problem. So this first one says graph the parametric curve on the parametric interval given, and it gives us a function for x and a function for y. So we're going to begin by taking this right here and plugging it into a graphing calculator, and then this interval is going to tell us what value of t we are going to use. So parametric equations usually give you an interval, and if they don't give you an interval, then you can just usually it'll default to either negative infinity to infinity or 0 to 2 pi for when we're dealing with circles, but more on that later. But in this case, they're actually giving us an interval, so they are telling us specifically, hey, the lowest value for t is going to be -3 and the highest value for t is going to be 1. And we could go ahead and graph this by hand, and we could say, well, x is going to be equal to -3 squared minus 2, which gives us x is equal to 9 minus 2, which gives us x is equal to 7. And we can also go ahead and say y is equal to 3 times -3, which means that y is equal to -9. So one of the points should be 7, 9. And this is the basic premise to graphing a parametric equation. Now, there are ways to do this on a graphing calculator, so I'm about to show you guys two ways. The first way is going to be with something that everyone should have access to, which is Desmos. Again, this is an online graphing calculator that you can use, and they actually do have a way to graph parametric equations, even giving the intervals. So the way you do it is you're actually going to give them a coordinate point of sorts. You're going to say, okay, my x value is going to be t squared minus 2. So I'm going to put parentheses there. I'm going to say this is going to be t squared minus 2. And because this is given in coordinate points setting, then you know that that first value is going to be your x, and then that second value, which is 3 times t inside the parentheses, is going to be your y. You will notice that because Desmos has recognized this as a parametric equation, the ability to input an interval has popped out, and so we're going to put -3 all the way to a +1. And so we end up getting something that looks a little bit like this. And if we go back to this, we can see that the value 7, 9, 7 and 9 should be a point on my parametric curve. And as you can see, it is. So you can see it starts here and then goes this way. Another way that we can graph this is by using TI Nspire. Once you're here, you would go ahead and add a calculator. And if we go ahead and click on Menu, Graph Entry, and Edit, there is an option for us to input a parametric equation. And so as you can see, it looks different than Desmos. This time it's asking you to separate your x value, your function of x and your function of y. So the function of x was t to the power of 2 minus, was it 2? Yes, it was, minus 2. And then my y value was going to be 3 times t. And we also have to go ahead and fix our interval. When we press enter, we graph it and we see that it looks pretty much the same as what we got with Desmos. So either one of these is going to be okay. Whichever one you want to work with is fine with me. Just know that I just think it's a good idea for you guys to be well versed in both of them. Now let's talk about eliminating the parameter. So changing something to a rectangular form. So if I'm trying to eliminate the parameter here, what this is telling me is that it wants me to change this into y is equal to a function of x. So I no longer want that t. I no longer want that extra variable in there. I want to go ahead and get rid of that so that I just have my x and my y. And the way I go about doing that is simply solving for either x or y. Now usually you would go ahead and solve for the easier one, or if you know you're going to end up in this format, you can solve for x first. That way you can have y is equal to a function of x. So for that reason, I'm going to go ahead and just solve for x first. You go about doing this by subtracting 1 from both sides. So I end up with x minus 1 is equal to negative 2 times t. And when I divide by negative 2, I get t is equal to negative x over 2 plus 1 half. Now this 1 half, remember, is a negative divided by a negative, so we're going to get a positive 1 half right there. When I go ahead and find my value of t, what I'm going to do is I'm going to then plug that into my function for y. So y is now equal to 2 minus, and instead of plugging in t, I'm going to plug in whatever I got for x. So negative x divided by 2 plus 1 over 2. And so now here I'm going to go ahead and distribute that negative. And what I'm going to get is y is equal to 2 plus x over 2 minus 1 half, or we could say 0.5 to make it a little bit easier on us. And when we combine our like terms of 2 and negative 0.5, we end up with y is equal to x over 2 plus 1.5. And so now we have a linear function that is the same as this parametric equation. So we have eliminated the parameter, but both of these are going to be exactly the same if we were to graph them. Now, let's say you wanted to go the other way and you wanted to add a parameter, or you wanted to go from rectangular form into parametric form. That's actually a very simple process. It's one of the easiest things that you guys can do in math. Let's just take any equation that we want, 2x squared plus 1, for example, right? And I want to add a parameter to this. I want to turn it into a parametric equation. The easiest thing for you guys to do is going to be to go ahead and take this and separate this into x is equal to t. So by simply equaling x to t, I am separating it from my y value. And because x is equal to t by itself, all I need to do is I need to rewrite it. Y is equal to 2 times t to the second power plus 1. And you see, now this is a parametric equation because x is a function of t and y is a function of t, and x and y are not functions of each other technically, but you don't overcomplicate your life. And both of these, you can see, are very simply equal back to your original rectangular form. So don't overthink these. These are pretty easy, and I like them a lot. They're not difficult at all. Now let's talk about the graph of a circle. So if I wanted to graph a circle, this is the parent function for a circle, right? X squared plus y squared is equal to r squared, and this right here can be changed into the rectangular form of this. You would go ahead and subtract x squared from both sides, and you get y squared is equal to r squared minus x squared. And if you were to take the square root of both sides, you'd get y is equal to the square root of r squared minus x squared. And you could definitely graph this. Let's try Desmos. The square root, y is equal to the square root of r would be any number that we want. So let's say 3, for example. 3 to the second power minus x to the second power. And you see the problem that we run into with this is that when it comes to graphing functions, the rule that we always have to follow is the vertical line test. So if I were to graph a full circle, and I would get this bottom semicircle, then this function would no longer pass the vertical line test. And for that reason, we cannot technically graph a circle with one function. We could do it with a relation, but we're not really looking to do that. So the parametric equations allow us to sort of bypass the vertical line test. And by giving us the equation of this circle right here, x is equal to 2 times the cosine of t, and y is equal to 2 times the sine of t, with the parameter interval of 0 to 2 pi if we're in radians, of course. So we need to be in radians for this. Then we're able to graph a circle. That right there, that number is going to be the radius. So if you have 2 and 2, then you would have a circle with a radius of 2. And this right here is going to just simply be the angle. Now, if you aren't really sure what we're doing, let's take 90 degrees, for example. All right. So let's just go with x. X would be, and let's say this is a unit circle, the cosine of 90 degrees. And we know that the cosine of 90 degrees is actually going to be 0. And the sine of 90 degrees, which is going to be my y value, is going to be 1. So here we would have the point 0, 1, which if we had a unit circle, or if we had a circle on a graph, it would be right here. And so this parametric equation is going to allow us to graph every single point for every single angle that we can find, whether we're in radians or degrees, it doesn't really matter. But there are a couple things to take note of. First of all, this is going to be the radius, or this is going to be the width, we could call it, of the circle, and this is also going to, and the y value is going to be the height of the circle. So if we wanted to graph this full circle, this one we said had a radius of 3, so we can go ahead and say, okay, well, let's go ahead and put in the cosine of, 3 times the cosine of t, comma, 3 times the sine of t, with the parameter from 0 to 2 pi, which is 6.28 approximately. And we can see that we formed a full circle. Now, if I wanted to change this to a smaller circle, for example, I wanted to move it, make it have a radius of 2, I would just simply change that. And if I wanted to make this an ellipsis, which means that it's an oval, I guess is another word for an ellipsis, you could go ahead and just change this to making it either taller than it is wider, or wider than it is taller. And so by doing this, you can go ahead and manipulate circles using parametric equations. You're able to graph the whole thing, and you're not limited to just the top part or just the bottom part of a circle with one equation. So that's another very, very good reason why we would use a parametric equation instead of a rectangular equation.